Alright, ladies and gentlemen, welcome to Lab 4. This is the color change module where we are trying to take two LEDs and using a little bit of pulse width modulation and a watchdog timer, be able to change them to kind of go back and forth. So as one gets brighter, the other one gets dimmer. So we make purple with a red and blue LED. This is kind of the code. You can see using a duty cycle of 16 cycles, setting everything up, watchdog timer with 1 Hertz. If you scroll down, you can look at the interrupt vector on the watchdog and also see the code, essentially just using a complement kind of thing. We are using modulos, which are, I guess, not computationally efficient, but it's fine. Now we'll zoom out and run it. Blue. Back to red. You can see it's slowly changing. Alright, folks. There you have it. Module 1 of Lab 4. We'll move on to Module 2, using the temperature sensor. This is for the Lab 4 temperature changer. So the LED should change colors. When it gets hotter, it should be more red. When it's colder, it should be more blue. So you can see in my code, we're using the watchdog timer as a interrupt clock. Additionally, we're using the temperature sensor on the MSP40. You can see that with the ADC being enabled for interrupt channel 10, I think. If you look down, we're also setting up for timer A1 to output to the first and second pin. That's in order for the pulse width modulation. Scrolling down, the meat of the code. Essentially, the temperature sensor has an output which is converted into a Celsius temperature. If it's below 20 degrees Celsius, it's completely blue, and if it's above 26, it's completely red. Otherwise, it's somewhere in between. And that's pretty much it. We also have a little bit of an interrupt vector here, just to send it to low power mode. Let's see if it works. As you can see, it's now completely red after heating up the MSP430. And then as it cools down a little bit, and if I shake it, it should start turning bluish again. You can see it's like purple. Nope.